Okay, moving on to D. Let's figure out the break-even points for this problem. So what does break-even mean? Well, to start off with, the students who rented the tank had to pay $300. So they're $300 in the hole. They're going to need to sell enough balls, so X is going to have to be high enough so that they make back that $300 that they spent to rent the tank. So the question is, how many balls do they need to sell in order for that to happen, right? Well, initially, when they sold no balls, they had a profit of negative $300, modeling the cost of the tank. Eventually, they want that to hit zero. That would be the break-even point. And then after that, the more balls they sell, the more money they make, right? So I want to know, or we want to know, when this value y is going to hit zero, right? When will it hit zero? Because when it hits zero, that will be when we've paid off the price of the tank and can now start actually making money in our fundraiser. So solving for x here, we're going to bring the 300 over, change sides, change signs. So this is 300 equals 3. I'm going to put this as a decimal. 1.5x equals 300, and then divide both sides by 1.5. So x is 200. So if we sell 200 balls in our fundraiser, we'll break even. If we sell 201, we'll start actually making money, right? But we need to sell 200 in order to actually get any kind of profit. And we're going to graph this to give you a better idea of what's going on here. Okay, so we're going to graph this line here. We've already solved for y. I put it into slope-intercept form. That equation was y equals 3 over 2x minus 300. You should have that in your notes. And we're gonna graph that in our calculator. So again, we go to y equals. If there's anything there, just clear it. And let's put in 3 over 2 in brackets x minus 300. Okay. If you hit graph, and if you had standard window settings, you'll notice that you do not see anything. What? Okay, don't panic. We can fix this. Just go back to y equals for a second to look at our equation. The slope of this graph is positive, and it's 1.5 in decimal form. More importantly, the y-intercept is negative 300, right? And if you remember from our standard window settings, the bottom y value here was negative 10, right? The standard window settings went from negative 10 to 10 for y. So negative 300 will be way down far on the Cartesian plane, and our screen does not allow us at this point to see that intersection. So what we can do is we can make this window, the calculator window, go way down to 300 so we can see the graph crossing at negative 300. To do that, we're going to hit this button here, window. And it brings up this screen. And you'll notice the minimum value for x is negative 10. The max is positive 10. Minimum is for y is negative 10, and the max is positive 10. So I want the minimum for y. That will control how far down my graph goes. I want the minimum to be at least negative 300. But because I want the intersection to kind of appear somewhere in the middle of my screen, I'm going to make it go past negative 300, maybe negative 400. Okay, and let's just graph that much so far and see if we can see the line. All right, so there it is, right there. And it crosses at negative 300. Now this line is pretty shallow, okay, and it doesn't tell us a lot about the problem that we're modeling. It's shallow right now because our x values are our range for x values is really narrow. So we're going to increase the x values. That would be the x max, the maximum that x can be. And that will make our graph go more to the right so that we can see more of this line and hopefully give us an indication of what's happening here. So we're going to make the x max go to about 300. Let's see what that did. That's much nicer. Okay. I also want to make my graph go a little bit further above the y-axis here. Sorry, this is the x-axis. Go above the x-axis a little bit more. So I'm going to have to increase my y values, my y maximum, to make it go up. So I go to Window, go down to y maximum, and let's make that about 100. We graph that. Okay, so there's a decent representation of what's happening in this problem here, right? We have some students who paid to rent a dunk tank that cost $300, and we found that the cost per ball for a student to throw a ball at the dunk tank and drop a teacher into a big tank of water, the cost for that per student was $1.50, or 3/2. Right, that's what the value of the slope was. So let's see if this graph can help us understand anything more about that problem. Well, the slope is 3/2. We said that. That's the cost per ball. The y-intercept is -300. And that would mean that the cost just to rent the tank was $300. Right? It's like saying, I'll just show you the point here. It's like saying, if I didn't sell any balls, okay, I rented the tank and I set it up and I, opened my booth, but nobody came. Bunch of jerks. Nobody came into my booth. That whole event would cost me $300. So I would make negative profit, right? But if one person came, right, trace one, look at that, okay? Now I'm not so bad anymore. I've made $1.50, right? If 5 people came, again, I haven't made a positive profit, but I'm getting closer, right? I'm starting to pay off the value of the tank, right? At what point will I break even? At what point will I make enough money to pay off the tank? And then after that, I'll start making positive profit. This point right here, what is that value? Well, we have a value of 200 here, as we had just solved. 200 for x. If we sell 200 balls, look at that, we break even. We hit our profit of 0. Okay? So our goal now is to keep selling balls for students to throw so that we make positive profit. And you can see as we pick values greater than 200, like 210 or 211. Okay, there we go. Now we've made $16.50 after selling 211 balls. If we do 230, we make $45. Okay, positive profit. That's after taking into account the cost of the tank. And as we keep going up and up and up, we'll make more and more money. But the point is, the break-even point, the point at which we start actually making money in a good way, is right here when x is 200. All right?